Nice to see everyone. So, can I see how many people know someone with diabetes? Yeah, see, that's a lot of people. So I do think this is quite an impactful project. And the first moment I met Livia, I could definitely tell that she was on the right track with the development of solutions for people with diabetes, making it open source, running it under a DAO. Okay, I'm not going to waste any more time. Let's have Livia come to the stage and present GlucoseDAO.
Okay, yeah. So I'll start with a bit about myself. So, as background, I am not bioinformatician or programmer, I'm just an architect, but the important recommendation in this case is that I'm a type 1 diabetes, and I was kind of frustrating with what happened with CGMs. So we have the part about what is the thing. CGMs are the sensors, you can actually see one live on me, which measure continuously your blood glucose. You have basically a commercially available product which gives you reading of what happens during the day with your glucose level. Here is basically an extract and analysis over a week. You have this very interesting, well, you can call it a squiggly line if you want, where the game is basically stay between those two lines, so you are safe. You have to be in range, as you see the 78% time in range, not too low or not too high. For normal people, this is kind of usually achieved. For diabetics, it's a bit tougher. So here is basically the squiggly line for a longer period of two weeks. These readings are basically produced automatically. But what is the problem? The problem is we have this data as a snapshot. We don't have it like to analyze stuff about it, or the analytics are pretty poor. I started looking at it and I said, there are recurring patterns. I wonder why people don't look at it. And so I started searching studies. And studies actually showed very interesting correlation. First of all, that glucose variability is related to longevity. This was a study on Chinese centenarians, which proved basically that they were more, they had less variation actually in their glycate, HbA1, than their offsprings and their control group, meaning that they were more stable. They did not have like highs and lows like I have here. They tried to find if there's a direct correlation between the two. That's what the study entailed, that it might be. Other studies showed that, well, diabetics are using the CGMs, but also, well, non-diabetic people could use it, and why would they do so? And they gave a pretty good graphical description, schematics, let's say, of what it could be. I mean, for people like us who watch over their lifestyle and health in hope of living a longer, healthier life, it's actually kind of important. But also for athletes or people who are sports-oriented. They want to have better performance, and for such, they have to analyze their data. Here, it's more closely to my squiggly line graphics, where they had a greater cohort, and they wanted to see what happens basically after breakfast. And they had the timestamp, the time frame, and seen that there was literally an increase, basically, in blood glucose in the morning, where people usually either skip breakfast or have a very healthy, very satious breakfast to cover them for the entire day, in the classical version of we're having 2 meals, not 3 a day. This study, which is one of the last, was more interesting because actually showed direct relations between shapes of the graphs and the conclusion. This was made basically in the glucose-resistant test that is usually done in pregnant women. And for 2 hours, they test their glucose variation. And they actually said that there were two main shapes, biphasic and monophasic. And in the fact, the ones that had like monophasic were more likely to have a higher blood glycate than the ones with biphasic. So they directly correlated the shape with like an occurrence, which is pretty recent because it was published, I think, in 2023. And important because if they noticed this by just looking at some people during 2 hours, you would start to wonder what would happen if you'd look at a larger population for more hours, actually. And in these two last studies, we actually get into the domain of prediction. There was, a documentation, a paper and GitHub data set, where you could actually see that people have been struggling to have predictions over glucose values and basically to see which one is best. In this GlucoBench repo and affiliated paper, they basically tried models of predictions available on the market, openly available. And they ended up with this kind of charts, where basically they say how close it is to prediction. And most of them are not as close as they could be. And some of them, like the Gluformer, the one that was like proposed to be the best because it was Transformer latest model and so forth, didn't even have like RMSE and ME because, well, they couldn't use data. That was what the authors told us. We're like, you tested the others, and why is the last one without any such information? And they said, well, I can speak louder, don't worry. Well, we could have, but we didn't have enough data. That's what they answered. And I was like, why didn't you have enough data? It's because publicly available, there is such scant amount of data, literally. Because it's like the data sets that are available without accreditation institution or hospitals. It's about 180 people for 2 months. That's all the data they have. However, on the first day of RDD, I received literally the link submitted actually on 20th August this year, where they did a similar named model that is Gluformer with capital F, where they managed to get more data and to predict. They looked at a cohort, actually, not at individual, to predict basically their likelihoods of illnesses or associated risks. That's what they're looking at. And they had better indicators in this case. But still, their data is not publicly available. So if you want their data sets or their models, you can't access them. So you as a citizen scientist or whoever wants to try anything, even on their own, is not available. So I started, okay, you don't have data. Let's play with my own data. I had 5 years of continuous monitor data, which I gathered my own. I can do whatever I want with it. First of it, I tried to look at from the image part. So see, actually, these are examples of my first attempts at clustering. And visually, it can be seen they're actually similar in shape. The computer had no information. He had just the image, and the thing like clustered the images which are similar. And he managed to do quite well, I mean, on the first try, but not very efficient. So I still kept searching because I wanted something faster and more efficient. And while searching and discussing with other people, I've reached this kind of solution, which was GlucoseDAO. Because I said, okay, the first problem we had no data sets because they were blocked by institution, by big pharma. We don't care, they were blocked, they were not accessible. So we need to have a public data set. We have models, but we're not sure of how good they are because we can't have the data to test them. And maybe there would be more models if people were free to experiment, which would do if they had with what to do it, obviously. So that's why we have to try the models. Also, why established this DAO? Because you have to have something like a structure, which is not really a company, but to have sort of an organization to allow you to like get the data, promote people, promote their ideas, and so forth. So that's how I came with the idea of basically GlucoseDAO. That was in May this year. Uh, After May this year, we had some progress. So this is an extract from a poster figure presented at the RDD, where we presented the actual glue former transformer that was mentioned previously, which managed to predict really close to what happened, trained on the 5 years of data. So the people were right. Their code was good, but it couldn't have been proven because they were not publicly accessible. We just trained it on the data, and you can see there in the, I can't go there because the projector would like shadow. You see the red line, that's the prediction basically. The blue line is what actually happened, and you can see how close they basically are. But this raised new questions, of course. And the question would have been, is it better if we use more data sets? I mean, if we have more people, should we have a foundational model which you overfit for each person or not? But for that, it's a vicious circle, returning to, we don't have data to test it on. So we first tried to see how accurate it was with what we've got. And basically, you can see that all of these figures, which the highest is 17.53, are actually lower than the ones we've got in the GlucoBench, where they tested the official data sets and the models that exist. So basically, with just one person's data, you manage to train a more efficient model than the ones available on the market with basically an open source code, which is really interesting because I've talked with representatives from universities, and they were like, you know, if you have more data, it starts to get fuzzier after 15 minutes. We managed to predict it for 1 hour in this part. So what did you try to achieve? Basically, this is kind of a very schematic roadmap. We have to have the data gathering and model training and testing to see which way is better. And unfortunately, all this kind of go in parallel with intermittent stops because you don't have, you have a certain point for data, then you test it, and maybe by the time you test it, more data hopefully comes, and you can draw some conclusions on which to edit basically on the next phases. Because besides the part with, programming, coding, and so forth, there's also the part of community forming and networking. Because first of all, more people need to know about this. And, community forming, yeah, you have to have it because people are gathered around ideas. And, we have diabetic communities. I mean, there are forums. Most people there want, and obviously I would also want that, an app or something easy like to press a button and I have a prediction. That would be ideally, is what I would like and what I'm trying to get. But to get to that, I just press a button and get a prediction, you have to have all the background, literally all the programming or the schematics, all the logic besides, and the structure to support this. Because otherwise, you're fighting alone against the world, which is not the best. And we tried to gather, at first, I think I actually wrote to the producer of the sensors, and I was like, can you introduce some more analysis things? And the answer was a standard one, which was we would take decline. Okay, sorry. If that was the signal I was getting too long, sorry. That was really good, though. Okay, yeah. So, I'll leave the QR while I'm explaining. And they just gave a classical answer in which they said, we will take your suggestion into consideration, but nothing really actually happened. So at the moment, as a community, we're stuck with sensors that theoretically work, but just provide readings. You don't have like a prognosis for patients, for individuals. That's what I'm interested, because everyone is egoistic. We are interested by our own person. I care what my blood glucose does. I'm not really interested that in 30 years the whole community might have diabetes, but it can also be improved by the fact that I know what my blood glucose does. So it's kind of watching your interest that helps the interest of many indirectly. And most of the research that I've actually shown is studying cohorts of people. So in a group of 100 people, I don't know how many % are likely to develop. But no one speaks what happens about the individual. And kind of that's what I'm trying to do. So like having individualized glucose prediction that could help you in your daily life, which is more than actually the sensors producers do, taking into account the ratings of their applications on Google Play and other things. And on this wonderful slide, first is the LinkedIn of myself. The second is the QR for the presentation, in case you want to actually read the papers I quoted, because they have the DOIs. And the last one is the X page of GlucoseDAO, where I'll update other links, because I really want to keep it up to date, since people were kind of complaining I am not very active on Twitter and so forth. And so that was all. Any questions? Or? Thank you. Or I may need it. Yep.
If you have questions?
Yep. Oh, there.
Yes, perfect. Interesting topic. I was debating this morning with my girlfriend, and I was wondering if you think there's opportunity in GlucoseDAO to also help with the interpretation of existing studies. There's a lot of studies, I don't know, it says first eat grape before you drink club mate or something in the morning, and whether or not that actually is correct, you'll find studies going in each direction. I think it's very hard for a normal person that isn't employed as a PhD to, spend the many hours to integrate these studies and come to a conclusion.
That's certainly, it can help with that, because actually one of the studies quoted said that it might be actually true that the subject itself is more important than the generalization. That is basically also what you can notice in diabetics community. For example, if you just eat cheese which is you can have at the supermarket, one person may be totally fine, while another can go to 200, well, in the diabetic case, just from that cheese, because each of us have different metabolism, different substances, we process differently what we eat. We have different weights, heights, I don't know, and lifestyles. Maybe some people go to gym, maybe others like bike, not go to gym. So that's why the studies are confusing, because usually they use like a subset of people which can't really cover everyone. So if you read that, I don't know, a diet of keto works wonders, it might actually, but it's not entirely proven it will be like attuned to you. So I think that if you look into, wait a second. If we look into different individual variations, then that would be the solution. So
Because Livia experimented.
What?
Yeah, so just wanted to say, as a non-diabetic person who was Livia subject for 2 weeks, so the thing is, one of the optimal way will be just to see how, so for non-diabetic person, you don't have to wear it all the time. You can just play with it and see how it reacts to your exercise and how it reacts to the food you eat. For example, for me, Mama Liga was like crazy, making it way higher than ice cream. And such things, they depend a lot also on your microbiome, also on how trained you are and what is your metabolism. So that's actually what I suggest. And also I have to highlight that what Livia does. So actually in that paper, like latest GLUE former paper, they gave a lot of machine learning predictions about probabilities of diseases and other health outcomes on non-diabetic people based on CGM. So it has actually a big promise for non-diabetic people, and actually many in longevity community play with it already.
And actually, you can predict also other stuff than just what you've eaten with the glucose. So you can predict infections. For example, before I was like PCR'd with COVID, doesn't matter what, it was an infection. 3 days before, my graphs were chaotic. And I was like, it's a sensor error, happens, who knows, something went bad. But then on the third day, when I actually started like having symptoms, I was like, maybe the graphics were not wrong. I mean, it was something there. And well, you can actually see tiredness or liver exhaustion. But all of this is just based on my observations. They're not really based on scientific studies. And that's frustrating because they haven't studies. I would have liked to open a Google page and say, you have this. No. Okay. So,
Thank you.
Yeah.
So